Welcome back to our channel, where we explore fascinating algorithms and their applications. In today's video, we will dive into the world of graphs and discuss the breadth-first search algorithm. Whether you're a computer science enthusiast or just curious about how algorithms work, you're in for a treat. So let's get started with our exploration of breadth-first search. Before we jump into the algorithm itself, let's quickly cover some basics. A graph is a data structure that consists of nodes or vertices connected by edges. These nodes can represent a variety of things, such as cities in a transportation network, web pages in a hyperlink structure, or even individuals in a social network. Graphs provide a powerful way to model and analyze relationships between entities. Breadth-first search, BFS, is a graph traversal algorithm used to explore all the vertices of a graph in a breadthward motion. It starts at a given source vertex and explores all its neighboring vertices before moving to the next level of neighbors. BFS is commonly used in artificial intelligence for tasks such as finding the shortest path, analyzing network connectivity, or exploring state spaces. Here is a step-by-step explanation of the breadth-first search algorithm. Step 1. Start by selecting a source vertex to begin the traversal. Step 2. Create an empty queue and include the source vertex into it. Step 3. Create a Boolean array or set to keep track of visited vertices and mark the source vertex as visited. Step 4. While the queue is not empty, repeat the following steps. Dequeue a vertex from the front of the queue. Process the dequeued vertex. Example, print it or perform any desired operation. Enview all the unvisited neighbors of the dequeued vertex. Mark each visited neighbor as visited and enview it. Step 5. Continue this process until the queue becomes empty. Step 6. If there are any unvisited vertices remaining in the graph, select a new unvisited vertex as the source and repeat the process from step 2. Let's go through an example of breadth-first search, BFS, to illustrate how the algorithm works. We will consider a simple undirected graph with 5 vertices, A, B, C, D, and E. The graph can be represented as follows. We will start the BFS traversal from vertex A. Step 1. Begin at the source vertex A. Step 2. Enview vertex A into the queue and mark it as visited. Step 3. Dequeue the front vertex from the queue, which is A. Process A. Print or perform any desired operation. Step 4. Enview the unvisited neighbors of A, which are B and C, into the queue and mark them as visited. Step 5. Dequeue the front vertex from the queue, which is B. Process B. Step 6. Enview the unvisited neighbor of B, which is D, into the queue and mark it as visited. Step 7. Dequeue the front vertex from the queue, which is C. Process C. Step 8. Enview the unvisited neighbor of C, which is E, into the queue and mark it as visited. Step 9. Dequeue the front vertex from the queue, which is D. Process D. Step 10. Dequeue the front vertex from the queue, which is E. Process E. Step 11. The queue is now empty. Since there are no unvisited vertices remaining, the BFS traversal is complete. In this example, the BFS traversal explored the graph in a breadthward manner, visiting all the vertices reachable from the source vertex A. The order of traversal was A, B, C, D, and E. BFS guarantees that it will visit all the vertices in the graph, and if the graph is connected, it will visit each vertex exactly once. It is important to note that the order of visiting the neighbors is based on the order they were enqueued, ensuring that the vertices are visited in a breadth-first manner. I hope this example clarifies how the BFS algorithm works. One of the main applications of BFS is finding the shortest path between two nodes in an unweighted graph. It's also used in solving puzzles, network analysis, and even in constructing game AI. Thank you for joining us today as we explored the breadth first search algorithm. We hope you found this video informative. So make sure to subscribe to our channel and stay tuned for more in-depth videos exploring the world of AI and cutting-edge technologies. If you have any questions or ideas for future videos, let us know in the comments below. Until next time, keep exploring and embracing the wonders of technology. See you soon.